All right, peeps, here we go. This one we're going to do a little talk beforehand just because we got some random stuff going on. I'm in Vermont right now. It's summertime, and yeah, it's raining about 7 inches today. That's what they're expecting. And because of that, there's like tons of landslides and stuff, and just road blowouts. This town, here, I'll give you a look in the background if you can see it. Yeah, it's been doing that for about like 12 hours now, and it's not going to stop for another like 14 hours or so. Um, Here's how this is going down. There's three ways out of the town that I'm in right now, and two of them are shut down. So if this video goes out, it's because I lost internet. So, and probably power. Yeah, so just some pictures that my friends are texting me. Share a little bit with you. Let's go here. This one right here is from a this couple just got married. Yep, that's a tree trunk just floating down, which is normally a stream, by the way, not a raging river like that. Yep, got that going down. Got a couple of here. That was a bridge that people were repairing. Gonna have to do a lot more repair to it. That was a bridge again. Oh, there's a car. You can see what barely see the windshield. This was a downtown shopping area. It looks like a cappuccino overflowed and just drowned it out. Yeah, there's another picture of Cappuccino Land right there. That was hours ago, by the way. There's the bridge again, just washed out completely. That was a nice little stream going underneath. Right there, it's all like one big lake. So, yeah, why I'm bringing this up is just because climate change. People mistake global warming and climate change all the time. Climate change is how our world is basically adapting or changing, for lack of a better term, and the things we have to do to make up for it. In New England, we can experience more sporadic weather where it can go from drought to like flood, drought, flood, drought, flood. It means we get a lot of our moisture all at the same time. Also, they're expecting that winters will have a lot more precipitation. That does not mean that we'll have more snow. What that means is up here, like in Vermont, you'll have snow followed by rain, which will increase the flooding. And um, flooding is not and rain are not as useful to the land as snow because snow gradually melts into the water table, keeps that water table nice and healthy. Rain just hits and flashes right out to the ocean. So, as you can see out there, I mean, it's just hitting pavement, going right down the drain. So, yep, just different stuff. Okay, to this now. Get rid of that. Chapter 6, Atmospheric Systems and Society. 6.1. You should have completed that one on your own. All right, that one's not too long. 6.2, Stratospheric Ozone. Introduction to Ozone. You probably have heard about the ozone layer. The ozone layer, it's actually thin, it's not that big. So, word comes from the Greek for smell. You can actually smell it if you've ever been in a copy machine room in like a school, and like you got a teacher who's like racking off thousands of copies. It just has a certain smell to it. That's ozone. It's produced by lightning. It's also produced by copy machines. You can smell it with that much electrical output. Ozone is O3, but usually breaks down to O2 very fast. That means one of those bonds breaks. Um, it's in the atmosphere in two layers. The stratosphere, which is a good thing. It blocks that UV radiation from coming through, so it keeps your eyes good, keeps you from getting cataracts. It also keeps you from getting skin cancer. Talking to from a skin cancer survivor. Well, at least I got a spot that I had removed from my back. Always got to get checked out now. I like it when it's in that stratosphere layer. It is not so good if it's in the troposphere layer. So, yep, that's a bad thing. It is a greenhouse gas, so the ozone does trap heat. Yep, keeps it from getting out into space. The ozone layer, it's in the lower stratosphere. It's a thin layer, usually 20 to 40 kilometers in altitude, depending on where you are globally. If you are closer to the poles, it's closer to you, so it's closer to that like 20 kilometer category. If you're by the equator, it is way up high, closer to that 40 kilometer um, thing, which is actually good because I would think having the ozone layer higher up, you get more UV radiation if you're closer to the equator. So, yep. Define dynamic equilibrium for me. So, yep, gotta look that one up. Both formation plus destruction absorb UV. So, um, so the formation of the ozone and the destruction helps absorb UV, which is a good thing. Absorbing UV breaks O2 into oxygen plus oxygen, like an individual level, which is good. Like so, it takes like two O2 units and goes and breaks them up. So now they're just individual oxygen atoms. It then combines them back into O2 to make O3 eventually. So O3 can absorb UV and reverse the process. So, which is good. Without ozone layer absorbing UV, we'd be screwed. Yeah, like if that UV light was hitting the earth, you'd see it genetically deform the DNA of plants. Plants would die out. We would die out because of UV radiation. So we need the ozone layer. It definitely is good for every single human being on the earth and necessary. Um, Ozone layer absorbs the vast majority of UVC and UVB rays. There is a difference in like UV rays A, B, and C. So, effects of ultraviolet radiation, damaging effects, cataracts. Yeah, let's look up cataracts for a second. Cataracts, yeah. If you've got an old dog, you might have seen these before. They're like this white film that can be on somebody's eyes like that. They happen on dogs. So, cataracts are kind of nasty. They keep, you just don't want to interfere with your eyesight. So, yep. Mutating DNA. Um, because UV light takes that double stranded DNA and just plays around with the genes, makes you a genetic mutant, not like the X-Men or like any of that stuff, not in a good way. Skin cancer. Yep. Once you start altering DNA, it makes you more susceptible to that. Decrease the immune system. Yep. Then you get sick for things around you, not just COVID. Uh, Damages phytoplankton and zooplankton. So that's the base layer of the food pyramid for the ocean. So it'll basically really mess up the ocean's food chain. So draw cataracts for me if you can. Medical this question. Describe the person that is most at risk for skin cancer. Here's a hint for you. You're looking at him. Um, if the phytoplankton, zooplankton decrease, what habitat and food pyramid does this mess up? Oh, dang it. I gave you the answer to that a minute ago. So, beneficial effects. UV radiation stimulates vitamin D production to build strong bones. So, you do need some of it, but guess what? We've got more than enough. It's like salt in our diet. Most people have more than enough salt in their diet. Name a disease or syndrome that causes weak bones. Oh, I gotta highlight that. Sorry, you got it. That one's gonna be green, just like that. Um, UV light they do actually use to treat psoriasis and vitiligo. I don't know if I pronounced that right. That is a new one to me. So, um, they also use it for eggs to make sure the bacteria on the outside of the eggshell is dead. So you can use UV light to kill off a lot of things, whether it's bacteria on an eggshell or it's the dead skin on the outside of your skin, obviously, on your epidermis. So sterilize the surface by killing bacteria used in air purifiers. Hello, COVID, right? Yep, UV light be used in to kill that COVID virus, I guess. Water purifiers camping and emergency survival. I might be using that later on today. Why? Because if I lose power here, the well needs electricity to pump water, and I will not have water. So I will have to go out there, get some of that nasty water. All right. Try to filter as best I can. And then I'll be using a UV light to basically make sure any of the bacteria in it are good and dead. Eggs disinfects the outer shell. It's used in lasers, forensics, lighting. So, yep. Air pollution in the ozone hole. Ozone above Antarctica measured since 1950. Yep, we've been at it since the 1950. That's even before Jay-Z's rap career started. So, the hole in the ozone layer was noticed and has increased. So, yep. And we realized we were contributing to it. I feel bad for having to do this. This is ripped right out of the book, but they basically did it better than I could in a table. You will copy down this whole table. Ozone depleting substances, ODS. Substance, CFCs for short. This is the only time you're going to hear me call it something other than a CFC. Chlorofluorocarbons. All right. They're used in propellants and spray cans and aerosols, spray paint, stuff like that. They release chlorine atoms. So, yep. Generally, those basically the chlorine atoms interfere with the ozone, with the oxygen breaking down and blocking UV light, and really messes up. The problem is too that they have a long lifespan in the ozone before they go away. We're talking like 100 years. So, yep. Chlorofluorocarbons, HCFCs, as replacements for CFCs. They're better, but not by much. Release chlorine atoms, but have a shorter lifetime in the atmosphere, stronger greenhouse gas. So they actually trap heat more, but they don't destroy the ozone as much. So, I mean, it's just, you know, I wish we had a better system for it. I really do. That might be the next thing for engineers to work on right after batteries and energy and drinking water, for the future. Halons, fire extinguishers. Yep, release bromine atoms. Actually, it's so rather nasty, but they used to run a marathon here in Vermont, right like maybe a quarter of a mile that way, up this one access road. And they used to, at the finish line, just have the fire department blow out their fire extinguishers right on the road. And yeah, all those things are very bad for the, obviously, for the ozone. However, though, they also put out what are they, PFCs, which go down into your water table, and any of the water that's like right below the hill here is actually loaded with carcinogens, which cause cancer. So, yeah, one more reason why you don't really want to be spraying fire extinguishing material unless you really got to. Release bromine atoms. Methyl bromide is a pesticide, releases bromine atoms. So, nitrogen oxides, often summarized as NOx. Bacterial breakdown of nitrates and nitrites in the soil, intensive farming. So, look, they add nitrogens to soil, usually through manure or through other sorts of, not pharmaceuticals, fertilizers. Okay. High flying supersonic aircraft as well. The nitrogen oxides are converted to nitrogen oxide, which reacts with the ozone. Again, not good. So copy this table down for me just so you get a baseline of what's going on. All right, CFCs and HCFs are important to know. Yeah, you want to know those. All right. Let's get to the point where we're right there. The action of ozone depleting substances, ODSs. CFCs were developed in the 1930s. They were developed for refrigeration. Before that, you just had an ice box. Let me see if I can get you a picture of an ice box. Put in there old ice box. Boom. All right. So back in the day, what they used to do is they used to basically farm ice. They'd wait for the winter and they would cut blocks of ice out of a lake or pond, and then they would put it in a barn and fill the barn with sawdust because it works good as an insulator. And then a guy would come around just like Amazon does nowadays in a pickup truck, but they would have a cart and they would just load a block of ice into your ice box, and it would actually help keep your food cold for a while. It also allow you to chip away ice and put it in your drink. So, and they used to export ice here in New England all the way down to the Caribbean and other places. So, yeah, who would have thought? Water freezes and you get to sell it other places. So this is what you had before you had refrigeration. But in the 1930s, they developed refrigeration, this material. It was used in propellants and aerosols down the road. They used it in glass blown plastics, used it with pesticides. Oh man, yeah, that was nasty along DDT. Flame retardants, which are basically the stuff the fire department sprays, like I was talking about. But the main thing was refrigerants. Yep, air conditioning later on, but refrigerators and freezers right off the bat, 1930. Yeah, made running a restaurant so much easier, made households so much easier. So CFCs are stable at ground level, but when in the stratosphere, UV makes them unstable and they break. So chlorine atoms break away from the CFCs. Chlorine reacts plus destroys the ozone. Chlorine prevents ozone formation as well. So not only does it destroy it, it prevents new ozone from forming. Chlorine then reforms and starts the destructive practice over again. So it loops. So it's a positive feedback that keeps destroying the ozone. And as you know, it's got a long lifespan, like 100 years. So it does it for a very long time. Replacing spray cans, CFCs is easy. CFCs and refrigerants is harder. Why? Because CFCs are not really flammable at ground level, where a lot of the replacements are. Look, I love the ozone as much as the next person, but I also don't want my refrigerator becoming a flame throwing household threat. So, um, just saying. Yeah, where are we? Oh, yeah. Old school refrigerants are flammable, dangerous. So, HCFCs, hydrofluorocarbons, are most likely replacements for CFCs. The problem is they're greenhouse gas. They trap more heat than CFCs. They also still mess up the ozone. It's just they don't do it for as long. So um, CFCs can live in the ozone for hundreds of years. Actions to reduce CFCs will take time to see results. It is now 2023. So yeah, we're still paying like the initial CFCs that we used in the 1930s will still be around for the next 10 years. And that's the first CFCs that we've ever used. So it's going to take over 100 years for these things to get out of this ozone system. So while they're up there, they're still damaging the ozone. Let's see down here. All right, reducing ozone depleting substances. Replace glass blown plastics. Yep, easy enough to do. A lot of times they'll use air and other things for that. CFCs with carbon dioxide, propane, air. So, yep, replace them with those. Aerosols with pump action spray cans. So, think of your Windex bottle. Instead of it being like the end dust, you go and it sprays it. So, um, pesticides with methyl bromide. So that I don't know as much about, but yeah, hopefully it does good. Regulate and reduce. Recover plus recycle CFCs from AC and fridges. So look, air conditioner leaks are a very bad thing. Same thing with your fridges. So, and this goes for your household and car. If you have a leak in your air conditioner on your car or your home AC, don't just be like, oh, let's put in some new CFC or HCFC, some new Freon. Find where the hole is, plug it, or get a new unit, and then put that in. Because if you just keep bleeding it out into the atmosphere, it does very bad things. So, Manufacturers then changed to non-ozone damaging chemicals. So countries came together to ban CFCs. We'll learn about that with the Montreal Protocol. So UNEP, United Nations Environmental Programmer, makes international agreements. Yep, we can all get along for this one. We all need that ozone. Otherwise, we all come down the bad case of dead. So studies the effectiveness, implementation, and enforcing agreements. That's interesting too, the enforcing of agreements. Yep. Everybody can agree to everything. Think of all those political promises you've heard. Show me what you actually have done afterwards. Informs others and educates them. Montreal Protocol, 1987. This agreement with 197 countries. At the time, that was all the countries in the world. Its job was to phase out ozone depleting substances. India and China have agreed but haven't complied yet, though they do have plans to do so. Look, the reason why those two have not complied is because their economies are booming, their populations are really out of control. I don't want to say out of control, but growing. And they look, they're hungry for energy. They're hungry to get up to that developed country status. They're hungry to bring in refrigeration, especially because a lot of their climates are pretty dang hot. So yeah, it makes everything more productive. So, yep. What is the Paris Climate Agreement? You could look that up. It's like 196 countries agreed to it, I believe. The United States, we backed out of it with President Donald Trump, although we did back into it with Biden. Um, who funds it? Yep. Who funds economically developing countries becoming more green? You know, um, who is President Trump? What was President Trump's reasoning for pulling out of it? Not saying he's wrong, not saying he's right. There's nothing that's very little in this world that's black and white. Timeline in CFC reduction 1970s. CFCs identified as ozone depleting substances. USA and Sweden ban it immediately. Yeah, we were forerunners for that one. So, yep. In 1985, the Montreal Protocol was organized. We got all the boys together, girls too. We're going to make this thing politically correct. We got all the peeps together. Said, all right, look, this hurts everybody. In the 80s, we're all a bunch. Well, we got still the Cold War going at that point, but this is a pretty good step towards like us all getting along and agreeing on something that could really mess us all up. 1990, the London Amendment speeds up the Montreal Protocol. This industrialized countries eliminated CFCs by 2000, 2010 for developing countries. So we realized the Montreal Protocol was onto something, but we needed to speed it up and we needed to get some timelines going. So by 2000, your country in Europe, you're doing pretty good. You should be done with CFCs. You're a country that's, a little, that's not as economically advanced. You got till 2010. So 1992, they furthered the measures even more. They sped it up even more. 1995, the Nobel Prize for Chemistry award to scientists working to solve the ozone depletion problem. In 2006, NASA and NOAA record the largest ozone hole yet. And again, think of it this way: it's because those CFCs are up in the atmosphere, and they will be. Every CFC that's put up there has got 100 years of living. That's longer than I have. So, significance of the Montreal Protocol. Hey, let's get together. Let's do some positives. This is the best example so far of like all the countries in the world getting together to work on a problem that's environmental that affects all of us. So, it's good that it's a precautionary action off of science knowledge. It's like, you know what? If scientists can predict meteors, if they can predict quite a bit, they're predicting this is a very bad problem. Let's be proactive and work on it before it is instead of reactive. Experts from different fields working to identify the problem and solve it. That's what we call good engineering. Peeps all right with different countries phasing out at different rates depending on the economic ability. Look, I've got family in Puerto Rico, and although it is part of the United States, it change occurs a lot slower there. My stepfather owns a gas station. Growing up, we had credit cards you could pay at the pump, and that was over 25 years ago. They still do not have that in Puerto Rico. Yep. So it's just different. It's the first agreement with regulations monitored. So, yeah, monitor, and it's good. I'm a big fan of monitoring, and I will say that if I'm going to be donating money to a cause, I want results. It's kind of like when your parents pay for your education, your phone, your car, your housing, anything. They pay, so they want to see certain things going on. Same thing for me. If I'm paying my money towards something that's supposed to be happening, it better be happening. So, all right, peeps. Hopefully you're doing well. Hopefully we still have power, and oh yeah, hopefully we don't have a landslide out there. So, all right, my best. Bye.